Hi, this is Lakshmi Prasna. I'm studying Adishankar Institute of Technology final year. I'm talking about my full semester internship, DSC with Java. I'm course outcomes demonstrate the theoretical learning outcomes, integrate theory and practice during graduation, comprehend the industry practices in the relevant and allied field of study, develop communication skills in terms of oral, written, and graphical communications, develop problem solving skills, develop work habits and teamwork in a multidisciplinary setting for a successful career after graduation. At the end of the course, I am able to strong foundation in core Java concepts, practical understanding of OOP principles, encapsulation, inheritance, polymorphism, abstraction, implementation of key data structures using Java, problem solving using arrays, strings, linked list, stack, and views, knowledge of sorting and searching techniques, understanding of recursion, algorithmic thinking, ability to write efficient and optimized code, improving logical thinking and preparation for technical interviews. Core Java is the basic foundation of Java programming. It includes fundamental concepts required to build simple applications. Core Java focuses on syntax and structure of Java, basic programming constructs, object-oriented concepts, key topics covered, variables and data types, operators and expressions, conditional statements, if switch, loops for while, do while, methods and functions, expansion handling. Variables are used to store data in a program. Data types define the type of data a variable can hold. Examples: int stores integers, float double stores decimal value, char stores single character, boolean true or false, string stores text. Operators are used to perform operations on variables. Types are arithmetic, relational, logical, assignment. Expressions are combination of variable and operators. Conditional statements are used to make decisions. Types: if statement, if else statement, if else ladder. Switch statements executes different code based on conditions. Loops are used to repeat a block of code multiple times. Types: for loop, while loop, do while loop. It can help reduce code repetition and improves efficiency. Methods are block of code used to perform specific task. Advantages: code reusability, better programming structure, easy debugging. Methods can take inputs and return outputs. Exception handling is used to handle runtime errors. Keywords: try, catch, finally, prevents program crashes and ensures smooth execution. Object-oriented programming is a programming approach based on objects and classes. It helps in organizing code in a structured and reusable way. Main principles: encapsulation, inheritance, polymorphism, abstraction. OOPs improve code reusability, security, and maintainability. Encapsulation is the process of wrapping data, variables, and methods functions into a single input. It also restricts direct access to data using access modifiers. Key points: data is hidden using private variables. Access is provided through public getter and setter methods. Improves data security and control. Inheritance is a mechanism where one class acquires properties and behavior of another class. Key points: parent class is a child class. Parent class, child class promotes code reuse, achieving using extends keyword in Java. Polymorphism means one name, many forms. It allows method to perform different tasks based on context. Types: compile time, method overloading, runtime, method overriding. Improves flexibility and scalability of code. Abstraction is the process of hiding internal implementation details and showing only essential features to the user. It focuses what to do, not how to do. Key points: achieving using abstract classes and interfaces, reduce complexity of code, improves maintainability, enhances security by hiding unnecessary details. Data structures are used to store and organize data efficiently. They help in performing operations like insertion, deletion, and searching easily. In this internship, the following data structures were implemented using Java: arrays, strings, linked list, stack. Use these structures to improve performance and optimize problem solving. Array is a collection of elements of the same data type stored in contiguous memory locations. Key points: fixed size can't be changed after creation. Elements are accessed using index. Provides fast access to elements. Examples: int array equal to 10, 20, 30. Int method array equal to new int size. Linked list is a linear data structure where elements nodes are connected using pointers. Each node contains data reference pointed to the next node. Key points: dynamic size can grow or shrink. Efficient insertion and deletion does not use contiguous memory. Stack is a linear data structure that follows LIFO, first in first out, last in first out principle. Operations: push, pop, peek. Push is used to insert element. Pop is used to remove element. Peek is used to view top element. Key points: insertion and deletion happen at the top, useful in function calls and recursion. Stack is a linear data structure that follows leaf. Queue is a linear data structure that follows FIFO, first in first out principle. Operations: NQ, Key points: first element inserted is removed first. Maintains order of elements used in scheduling and buffering. Problem solving involves using appropriate and data structures that algorithms to efficiently solve real world problems. No. In this internship, problems were solved using arrays, strings, linked list, stacks. Use focus was on improving logic building and coding efficiency. Arrays and strings are basic structures used in problem solving. Sorting arrays, finding duplicates, string reversal, palindrome checking. These improve basic programming skills. Linked lists are used for dynamic data handling, problem solving, traversal of list, insertion and deletion. Reversing a linked list useful when data size changes frequently. Stack and queue are used in specific problem scenarios. Stack problems, balanced parenthesis, expression evaluation. Queue problems, task scheduling, handling request in order. Sorting algorithms are arranged if elements in a specific order. Types covered: bubble sort, selection sort, insertion sort. Key points: easy to understand, useful for small data sets, help in learning algorithm basics. Searching algorithms are used to find elements in a data set. Types: linear search, binary search. Key points: linear search, binary search. Checks: linear search, it checks each element fast. Binary search, it can help faster and requires sorted array. Recursion is a technique where a function calls itself to solve a problem. Algorithm thinking is the ability to solve problems step by step logically. Key points: a reverse function must have a base case. It breaks problem into small sub-problems, improve problem solving skills. Example: factorial of a number. Efficient node means writing programs that use less time and memory. Optimized core improves performance and scalability. Key points: reduces time complexity, minimizes memory usage, improves execution speed, uses appropriate data structures. Techniques: to improve code efficiency. Use efficient algorithms, binary search instead of linear search. Avoid unnecessary loops. Reduce redundant calculations. Use proper data structures. Write clear and readable code. Logical thinking is the ability to analyze problems and find efficient solutions. This internship helped in improving problem solving and coding skills focus areas. Breaking complex problems into smaller steps, writing clear and logical code, practicing coding questions regularly. Preparation for technical interviews includes strong understanding of TSA concepts, practicing coding problems, understanding time and space complexity, writing optimizer solutions. It helps in cracking technical interviews successfully. Thank you, ma'am.